Hello friends, welcome to the channel All Competitions. In today's lecture, we are going to discuss different types of grammar. So basically, the grammar is classified according to the productions rule, second one is the derivation tree and number of strings. Okay, so one by one we are going to discuss here. The first one is production rule. So in the case of production rule, it is classified into type 0, type 1, type 2 and type 3. Okay, so these are the four types with respect to the production rule. Again, it may be also classified with respect to derivation tree. Second one is the so on the basis of derivation tree, it is classified into ambiguous and unambiguous. So what is meant by ambiguous and what is meant by unambiguous, we will be discussed later. Okay. And the last one, the third one, that is a number of strings. So basically in the case of number of string, it is classified as recursive and non-recursive. Okay, so these are the basic classification of grammar with respect to production rule, derivation tree and number of strings. In today's lecture, we are going to discuss how the grammar is classified into different types by using production rule. So basically you can see that is the relationship among the different grammars and which is also known as Chomsky hierarchy. Chomsky hierarchy, and which is invented by scientist Noam Chomsky or mathematician Noam Chomsky in 1956, and which is gives here the relationship among the different grammars. Okay, so the first one is the type 0 or unrestricted, and which is recognized by Turing machine. Then next one, here is the type 1, or it is called as a context sensitive grammar, and which is again recognized by Turing machine, or LBA, that is linear bounded automata. Then next one, here is type 2, it is called as a context free grammar, and which is recognized by push down automata. And finally, that is a type 3, which is accepted by regular grammar, and which is accepted by, that is a finite state automata. Okay, so that is the basic classification according to Noam Chomsky. It is called as a Chomsky hierarchy, which is deals with the production rule. Okay, so we are going to discuss one by one what is meant by type 0, what is meant by type 1, and so on up to type 3. Okay, so let us see one by one. So the first one, type 0. So in the case of type 0 grammar, let us consider the production rule. If alpha tends to beta is the production rule, then what is the possibilities in the case of type 0? The type 0 is called as a unrestricted grammar. It is also known as semi-through grammar. It recognized by Turing machine. It having recursively enumerable language. Okay, so these are the some properties, or these are the some things with respect to the type 0. If we have given the production alpha tends to beta, then what should be alpha and what should be beta? We have to discuss this one. What should be alpha and what should be beta? So alpha is nothing but sentential form of terminal and non-terminal symbols. Terminal and non-terminal symbol. And also beta is sentential form of terminal and non-terminal symbol. You can see here. Okay. And one more thing is that alpha should not be belongs to null. So that is the only restriction in case of type 0 grammar. Alpha should not be belongs to null. Okay, rather than this, any type of productions are possible in the case of type 0. That's why it is called as a unrestricted grammar. So let us see some examples here. Let us consider A tends to AB. Yes, it's allowed. AB tends to A, B, C. ABC tends to C, D. D tends to none. So these are the collection of some productions together, which is nothing but type 0 grammar, and which is recognized by Turing machines, or as I mentioned here, which is recognized by recursively enumerable language. There is only one restriction, that is a alpha, that is the left hand side of the production, should not be equals to or belongs to none. That is the only restriction in the case of unrestricted grammar. Okay. Another all possibilities are possible in the case of type 0 grammar. Now see the next one. Type 1 grammar, or which is also called as context sensitive grammar. Type 1 or context sensitive grammar. So let us assume here alpha tends to beta is the given production. Then size of beta should be greater than or equal to size of alpha. That is the additional condition with respect to unrestricted grammar in case of type 1 grammar or context sensitive grammar. Means what? Size of right hand side of the production should be greater than or equals to size of left hand side of the production, and there is a possibility that alpha should be tends to null. In this case, it having the exception, because in this case alpha definitely having size more than 1 or more than 1, and in the case of null there is size equals to 0. So in this case it is not possible to have size of beta greater than or equals to alpha. Means this one is only allowed. Okay, or you can say this one is the production which is spoils this rule. This rule is not followed by alpha tends to null. Okay, another thing is what? If alpha tends to null is present, alpha tends to null is present, and if alpha is a starting symbol of the production, and if it is present in the right side of the production, then it is not allowed in case of type 1 grammar. Means what? See, let us consider A tends to AB. Okay, AB tends to small c, capital D, A. Okay, capital A tends to again null. So if you see here, A is the starting symbol of the productions, and also this A is present over here, and I have taken this A tends to null. So as per the definition, this one is not allowed, because this starting production, that starting symbol A which is present in the right side of the production, and we have taken A tends to null, it is not allowed. Okay, so you have to remember this. This one is not allowed. You can take here B tends to null. There is no issue, because B is not starting symbol of production. Okay, so that is the example of type 1, or you can say context sensitive grammar. Context sensitive grammar, which is also recognized by Turing machine or linear bounded automata. Turing machine or linear bounded automata. And important thing is what? Size of right hand side in the production should be greater than or equals to size of left hand side of the production. Alpha tends to null is allowed. Alpha tends to null is allowed, but when alpha should not be present in the right side of the production and alpha is a starting symbol. Okay. Now see the next one. Type 2, or it is called as context free grammar. So in the case of context free grammar, let us consider alpha tends to beta is the production. Alpha tends to beta is the production. Then what are the conditions? The condition number 1, alpha should be single non-terminal symbol. Alpha should be single non-terminal symbol, means alpha should be belongs to phi, where phi is set of non-terminal symbols. So So that is the first condition. LHS, that is alpha, should having single non-terminal symbol. Then next one is what? Beta. With respect to beta, beta should be sentential form of terminal and non-terminal symbol together. Phi union T, clean operation. Then next one, it is accepted by push down automata. This type of grammar is accepted by push down automata. Okay. Then next one, some examples. S tends to small a, capital S, small a, or small b, capital S, small b, or a, or b. Or it is also simply written as, you can written this as S tends to A, capital S, A, S tends to B, capital S, B, S tends to A, S tends to B. So both having this one, this collection of production, and this one having the same meaning. So that is the example of context-free grammar. Okay. Now see the last one. Type 3 or regular grammar. Type 3 or regular grammar. So you can see here, if alpha tends to beta is the production given you, then alpha should be single non-terminal symbol. Alpha should be single non-terminal symbol. Then beta is nothing but sentential form which is made up of terminal and non-terminal symbol, and beta should contain single non-terminal symbol at extreme end of production. At extreme end of the production, what is the meaning of this? What I mentioned, beta should contain single non-terminal symbol at extreme end of the production means what? Let us consider non-terminal symbol A or maybe B or maybe whatever. It should be present at the, for example, S tends to capital A small CD, or S tends to CD, yes, it is also allowed. S tends to CD capital A, S tends to null is also allowed. So if you observe here, this capital A is present at extreme end, that is the LHS, extreme end of the right hand side production. Here A is also present at extreme end of the right hand side production. So this one, this one, this one, and this, all these are related to type 3 or regular grammar. So let us take another example. S tends to A, capital A, small a. Whether it is a type 3? No, it is not type 3, which is belongs to the previous type, that is a type 2, or which is called as a context free grammar. Okay, this is not an example of regular grammar or type 3. Okay, so I hope that you got this idea. Then according to the position, see, on the right side of the production, A is placed over here, A is placed over here. Okay, that is the extreme end of the right side of the production, and this is the extreme end of the right side of the production. So on the basis of that, it is classified into two types. The first one is left linear, and second one is right linear. Left linear regular grammar and right linear regular grammar. So if you see here, this one is the example of left linear, and this one is the example of right linear. So in the case of left linear, on the right side of the production, non-terminal symbol is present at extreme left hand side. Okay, and here non-terminal symbol is present at extreme of the right hand side. You can see this one. So that's why it is called as a right hand or right linear regular grammar, and this one is called as a left linear regular grammar. Fine. Then next one, yes tends to null. Yes tends to null means what? Null production is also allowed, but when the starting symbol S is not present in the right side of the production, then it is allowed, otherwise it is not allowed. Means what? If I take another production, S tends to A, B, capital S. Okay, then again let us consider, if I take S tends to null, then it is not allowed, because if you observe, this starting symbol capital S is present in the right side of the production, and we are taking here S tends to null. So this is not allowed in case of regular grammar, and generally the regular grammar which is accepted by finite state automata. Okay, so that's all about different types of grammars with respect to the productions rule. I hope that you got the different types we have discussed in the today's lecture. Thank you so much.